November 12, 1942. Western Desert, Libya. The sun hung low over endless sand, casting long shadows across the battlefield's debris. Captain Marco Bellini, chief engineer of the Regia Aeronautica's motor transport division, stood amid the wreckage of what had been a contested supply depot just 3 days earlier. British and American forces had swept through this position during a rapid advance, then retreated just as quickly when German armour appeared on their flank. The back-and-forth nature of desert warfare left landscapes littered with abandoned equipment, hasty decisions frozen in metal and canvas. Bellini was 34 years old, educated at the Politecnico di Milano, one of Europe's finest engineering institutions. He'd spent 8 years designing automotive systems for Italy's proudest industrial firms before the war pulled him into military service. He'd believed, as every Italian engineer did, that European technical sophistication would prove decisive in modern warfare. The Allies might have numbers, but the Axis had genius, precision, centuries of craftsmanship refined into mechanical perfection. That belief was about to shatter completely. His assistant, Lieutenant Giuseppe Romano, was 26, a graduate of Turin's technical school. Romano possessed the eager energy of youth combined with genuine mechanical aptitude. He'd been assigned to Bellini 6 months earlier and had proven himself capable, if sometimes impulsive. Now Romano was cataloguing abandoned equipment with methodical care, noting serial numbers, conditions, potential intelligence value. "Captain," Romano called out. "Something interesting here." Bellini walked over, boots crunching on sand mixed with spent brass casings. The battlefield smelled of burned cordite, leaked oil, and the peculiar metallic tang of destroyed machinery. Among the scattered debris, partially hidden behind a collapsed supply crate, sat a small vehicle, intact, undamaged except for dust and minor bullet impacts on its metal body. It was painted olive drab, the standard American military color, 4 wheels with tall, narrow tires, a compact body no larger than a civilian runabout. Flat hood, simple wire mesh grille, canvas top stretched over a basic tubular frame. American markings were stenciled on the hood in white paint, US Army and a serial number. The vehicle looked absurdly utilitarian, almost primitive in its simplicity. Bellini circled it slowly, his engineer's eye cataloguing details. The body panels were flat stamped steel with minimal curves, suggesting simple manufacturing processes. The welds were visible at panel joints, rough by Italian standards. No chrome trim, no decorative elements, nothing that wasn't purely functional. The bumpers front and rear were simple steel bars, practical rather than aesthetic. Romano kicked one of the tires, testing its pressure. "American toy," he muttered dismissively. "Looks like something a farmer would build in his barn." Several nearby soldiers laughed. Italian military vehicles, even the troubled ones, possessed a certain elegance. Curved fenders, styled hoods, details that reflected Italy's automotive heritage. This American machine looked crude by comparison. But Bellini wasn't laughing. Something about the vehicle's stark functionality intrigued him. He opened the driver's door, which moved on simple pin hinges with no resistance. The interior was Spartan. 2 front seats with minimal padding, a simple dashboard with basic gauges, speedometer, fuel, temperature, oil pressure, a floor-mounted gear shifter, pedals for clutch, brake, accelerator, nothing else. He found a logbook wedged beneath the passenger seat. Military documentation, filled out in English with handwritten entries. Bellini's English was functional, learned during his university years when he'd studied American industrial methods. He flipped through the pages, translating mentally. The vehicle had been in service since July 19th, 1942. 4 months of operation. The log entries documented distances travelled. 80 kilometres one day, 150 the next, 230 the day after. The final entry, dated 3 days ago, noted 187 kilometres travelled in the previous 48 hours across rough desert terrain. Bellini did quick calculations. Total operational kilometres over 4 months, approximately 12,000. That was extraordinary. His own Fiat trucks required major overhauls every 3,000 kilometers under ideal conditions. Under desert conditions, they lasted barely 1,500 before critical failures. He walked to the front and opened the hood. The latch was simple. The hood lifted to reveal the engine compartment. What he saw inside made him pause, his breath catching slightly. A small 4-cylinder engine, perhaps 60 pounds total weight, simple carburetor mounted on the side, basic distributor for ignition, belt-driven, fan for cooling. Everything was exposed, visible, accessible. But something was profoundly wrong. Bellini leaned closer. The oil dipstick showed minimal oil in the crankcase, far below safe operating levels. The radiator cap was loose. He removed it carefully. The radiator was nearly empty, and he could see a small bullet hole through the core where a stray round had punctured the copper fins. Coolant had leaked out over time, probably days ago. The fuel tank, visible beneath the rear of the vehicle, showed impact damage. Dents and scratches suggested rough handling, yet according to the logbook, this vehicle had travelled 187 kilometres in the previous 48 hours. Over 100 miles across desert terrain with minimal oil, no coolant, and a damaged fuel system. Impossible. Absolutely impossible. Bellini's Fiat 634 trucks weighed 3,000 pounds and featured sophisticated inline-six engines with aluminum cylinder heads, precision carburetors, and complex valve trains. They represented the pinnacle of Italian automotive engineering. They were also incredibly fragile. If a Fiat's oil level dropped even slightly, the engine would seize within kilometers. If the cooling system lost pressure, the aluminum heads would warp, destroying the engine completely. This American machine had apparently operated far beyond mechanical death and continued functioning. It shouldn't be possible. Everything Bellini had learned said that an engine running without adequate lubrication and cooling would destroy itself in minutes. "Start it," Bellini ordered, his voice quiet but firm. Romano looked skeptical. "Captain, it looks abandoned for good reason. The engine is probably seized up completely." "Start it, Lieutenant." "That's an order." Romano shrugged and climbed into the driver's seat. He examined the controls briefly, then turned the key. The starter motor cranked. Once. Twice. The engine coughed, sputtered, hesitated. Then it caught. The 4 cylinders fired with a rough, uneven rhythm. Valve clatter was audible. The engine wasn't running smoothly. But it ran. It idled. Rough, protesting, but functional. Bellini felt something cold settle in his stomach. This wasn't supposed to work. Every principle of precision engineering said this machine should be seized solid. The bearing surfaces should be destroyed from lack of lubrication. The cylinders should be scored from overheating. The valves should be burned from excessive temperatures. Yet the engine ran. Stubbornly, almost defiantly, it continued operating. He climbed into the passenger seat. "Drive," he said quietly. Romano engaged the clutch and shifted into first gear. The transmission moved smoothly. He pressed the accelerator. The engine responded. The Jeep lurched forward across sand and rocks. The ride was harsh, unrefined. The suspension was primitive, clearly using simple leaf springs. The steering required physical effort. Every bump transmitted, directly to the occupants, but the vehicle moved with confidence. Its small engine, despite abuse that should have killed it, pulled them forward without hesitation. Romano drove up a steep embankment, the kind that caused Italian trucks to struggle. The Jeep climbed steadily, its 4-wheel drive providing traction effectively. Bellini had watched Italian trucks fail on gentler grades. They drove for 20 minutes, testing the vehicle. The Jeep performed consistently, no overheating warnings despite the damaged cooling system, no oil pressure problems despite minimal lubrication, no fuel delivery issues despite tank damage. It simply worked. When they returned, Bellini made a decision that would change everything. "We're taking this to headquarters," he said firmly. "I need to understand what the Americans have built." Romano frowned. "Sir, It's just a light reconnaissance vehicle. Nothing special. Probably not even worth the fuel to transport it. Bellini looked at the Jeep again. Its engine still running despite abuse that would have killed any Italian motor. That, he said softly, is precisely what worries me, Giuseppe. Precisely what terrifies me. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand what Bellini had discovered, to comprehend the full weight of what that running engine represented, you must first understand what Italy had built, or more accurately, what Italy had failed to build. When Benito Mussolini declared war on France and Britain in June 1940, Il Duce's rhetoric spoke of Roman legions reborn, of Italian military might sweeping across the Mediterranean. The reality was far more modest. The Regio Esercito, Italy's royal army, and the Regia Aeronautica, the Royal Air Force, entered combat with a motorization rate that would have embarrassed most peacetime civilian fleets. The Italian military's transport backbone consisted primarily of requisitioned civilian trucks hastily pressed into service. These weren't purpose-built military vehicles. They were commercial trucks, ice delivery vehicles, grocery haulers, construction equipment, all suddenly expected to function under combat stress. The standard vehicle that was purpose-built for military use was the Fiat 634, officially designated the Autocarri Fiat 634. It was a 3-ton truck that represented Italy's attempt to create modern military transport. On paper, the specifications were impressive. These trucks featured sophisticated 6-cylinder inline engines with aluminum cylinder heads for weight savings, precision carburetors with multiple adjustment points, and complex valve trains requiring regular maintenance by trained mechanics. The engines produced 85 horsepower from 4.5 litres of displacement. On paper, they represented advanced European automotive engineering. In practice, under desert warfare conditions, they represented unmitigated disaster. The 634's engine weighed nearly 1,200 pounds, a massive lump of cast iron and aluminum. The truck's total weight approached 7,000 pounds empty, before any cargo. This made them heavy, slow, and nearly impossible to extract when stuck in sand, which happened frequently. The sophisticated engine required specific grades of oil, changed every 500 kilometers. In North African desert conditions, where temperatures exceeded 45 degrees Celsius, oil degraded even faster, breaking down under extreme heat. But oil supplies were inconsistent. Depots often provided whatever oil was available, regardless of specification. Wrong viscosity oil accelerated wear, destroyed bearings, led to catastrophic failures. The cooling system needed distilled water, or at minimum, clean water free of minerals. The aluminum cylinder head was particularly sensitive to corrosion and scaling. In North Africa, clean water was impossible to find. Wells produced water heavy with minerals. Oases offered water containing organic matter. Soldiers filled radiators with whatever water was available because the alternative was immediate seizure. The result was predictable. Radiators clogged with scale. Cooling efficiency plummeted. Engines overheated regularly. Aluminum heads warped from thermal stress, destroying the seal with the cast iron block. Head gasket failures became epidemic, so common that mechanics treated them as routine rather than unexpected. The carburetor was a masterpiece of precision engineering and a nightmare of maintenance. Multiple jets controlled fuel flow at different engine speeds and loads. These jets were tiny brass orifices, drilled to exact dimensions. Desert dust infiltrated everything. The jets clogged constantly, sometimes daily. Engines ran rich, wasting precious fuel, or they ran lean, overheating and destroying pistons. Cleaning the carburetor required complete disassembly, specialized tools, and hours of work. Field manuals specified carburetor service every 50 operating hours. Most Italian mechanics were conscripts with minimal training who lacked proper knowledge. They adjusted by guesswork, often making problems worse. The electrical system had been designed for Italy's temperate climate, not North African extremes where daytime temperatures reached 50 degrees Celsius and nighttime temperatures dropped to near freezing. This thermal cycling destroyed electrical insulation. Wires became brittle, cracked, shorted against frames. Generators failed, batteries discharged. Trucks that ran perfectly in the morning refused to start by evening. The differential housing used custom gaskets available only from Fiat factories in Milan. When those gaskets failed, and they failed regularly, gear oil leaked out. Without lubrication, the differential gears destroyed themselves. Replacement gaskets had to be shipped from Italy, assuming they were in stock, assuming shipping routes were open, assuming submarines didn't sink the transport ships. A stranded truck with a failed differential gasket might wait weeks for a part that cost almost nothing. Meanwhile, the vehicle sat immobilized, useless, representing wasted industrial investment. Bellini had witnessed this mechanical fragility firsthand. He'd commanded transport units in Libya since 1941. He'd watched convoys break down on schedule, stranding entire divisions without fuel or ammunition. By late 1942, Italian forces in North Africa were operating at barely 40% motorization capacity. This wasn't merely inconvenient, it was strategically catastrophic. The mathematics were brutal. Each Italian division required approximately 600 trucks to maintain supply lines. These trucks had to deliver fuel, ammunition, food, water, spare parts, medical supplies, everything needed to sustain combat operations. But mechanical attrition reduced available vehicles monthly in a steady, horrifying decline. In September 1942, the 10th Army reported 473 operational trucks against an authorized strength of 680, already operating at 70% capacity. By October, 381. By November, 294. The decline was exponential, accelerating as parts became scarcer and maintenance fell further behind. German forces, recognizing Italian transport inadequacy, began supplying their own vehicles to Italian units. Opel Blitz trucks started appearing in Italian motor pools. This was deeply humiliating for a nation that prided itself on automotive excellence. Italy had produced Alfa Romeo racing cars that dominated international competition. Italian engineers had designed vehicles that won Mille Miglia races, yet Germany was now providing trucks because Italian vehicles couldn't sustain operations. Bellini himself had studied at the first, Politecnico di Milano. He'd learned thermodynamics from professors who'd designed Alfa Romeo racing engines. He'd applied that knowledge to military transport, believing precision engineering would prove superior. Then, reality intervened. Desert warfare demanded different virtues. Durability over refinement. Simplicity over sophistication. The ability to function despite abuse, not because of careful maintenance. Italian trucks embodied old-world craftsmanship, built like fine watches requiring expert care. American vehicles, Bellini was beginning to suspect, were built like hammers, crude, heavy, designed to pound and be pounded. Impossible to break through reasonable abuse. The journey to Benghazi took 3 days instead of the planned 2. The captured Jeep rode on a flatbed trailer behind a German Opel truck. Bellini rode in the Opel's cab, using travel time to study the American service manual found beneath the Jeep's driver's seat. The manual fascinated him in unexpected ways. It was 32 pages long, printed on cheap paper with simple line drawings, 32 pages. The Fiat 634 technical manual was 304 pages of dense text and complex procedures. This disparity alone suggested something profound about design philosophy. The American document assumed minimal mechanical knowledge from users. Instructions were written in simple language, avoiding technical jargon. Remove the 4 bolts holding the valve cover. Lift the valve cover straight up. No torque specifications. No special procedures, just basic, clear instructions. Drawings were simple but effective. They showed exactly which bolts to remove, exactly how parts fit together. A soldier with no mechanical training could follow these illustrations successfully. The manual divided procedures by complexity. Level 1 maintenance could be performed by the vehicle operator, checking oil, checking coolant, inflating tires, replacing fuses. Level 2 required a unit mechanic, changing spark plugs, adjusting valves, replacing filters. Level 3 required workshop facilities, engine overhaul, transmission repair. But even Level 3 procedures were explained clearly, assuming basic skills but not specialized training. Oil change, 4 steps. Drain plug location shown. Filter replacement illustrated. Refill capacity specified. That was it. Spark plug replacement, 3 steps. Remove plug wires, unscrew old plugs. Install new plugs hand tight plus 1/4 turn. Reconnect wires in correct order. Carburetor adjustment was almost insultingly simple. 2 settings, rich or lean. Turn adjustment screw clockwise for lean mixture. Turn counterclockwise for rich mixture. Adjust until engine runs smoothly. No complex tuning procedures. Just simple adjustments any soldier could perform. The manual included troubleshooting organized by symptom rather than system. Engine won't start. Check these 3 things in order. First, fuel in tank. Second, spark at plugs. Third, compression in cylinders. If all 3 are present, engine will run. No complex diagnostic trees, no specialized testing equipment. Just logical problem solving that any intelligent person could follow. Bellini compared this to Italian documentation. Fiat manuals assumed university-level mechanical education. They included thermodynamic calculations. They provided metallurgical specifications. They featured electrical schematics requiring engineering degrees to interpret. They were comprehensive, brilliant, and utterly useless to conscript mechanics. The American manual was deliberately stupid. It assumed users were intelligent but untrained. It avoided complexity. It emphasized practical procedures over theoretical understanding, and that stupidity was genius. Because in war, most maintenance would be performed by young conscripts, farmers, shop clerks. The American manual made that possible. The Italian manual made it impossible. Predictably, the Fiat truck broke down after 180 kilometers. Fuel pump failure. The pump's internal diaphragm had cracked in desert heat. Romano and another mechanic spent 4 hours replacing the pump using a spare carried for exactly this predictable failure. While waiting, Bellini examined the Jeep's fuel pump. Simple design, lever arm actuated by the camshaft. The entire assembly weighed perhaps 2 pounds and could be replaced in 15 minutes with basic tools. When the convoy reached Benghazi 2 days later, Bellini commandeered workshop space in the Regia Aeronautica's maintenance facility. The complex sprawled across several acres, mostly above ground but with one section built into natural limestone caves for protected storage. Bellini requisitioned one of these underground spaces. The cave had been converted into a workshop. Concrete floor poured over limestone, electrical lines from a diesel generator, harsh lighting from industrial fixtures, adequate ventilation through natural rock chimneys. Perfect for detailed evaluation work, protected from air raids that were becoming increasingly frequent. He ordered the Jeep positioned in the center of the workspace. For several minutes, he simply walked around it, observing from different angles. The vehicle measured 3.3 meters long, 1.6 meters wide. Height to the canvas roof was 1.8 meters. These were modest dimensions, smaller than any Italian military truck. Total weight was approximately 1,000 kilograms, 2,200 pounds. His Fiat 634 weighed 3 times that. This weight advantage affected everything: mobility, fuel consumption, ease of recovery when stuck. Bellini began with systematic external inspection. The body panels were flat, stamped steel with minimal curves. This simplified manufacturing dramatically. Each panel could be stamped with basic tooling available in thousands of factories. No expensive multi-stage dies required. The welds joining panels were crude by Italian standards. Visible beads, occasional spatter, no finishing grinding, no cosmetic attention whatsoever. But the welds were functional. Every joint bore structural load. The Americans had eliminated aesthetic considerations completely. The bumpers were simple steel bars welded directly to the frame rails. No chrome, no formed shapes, no styling. Just straight tubes that could push, pull, or absorb impacts. The frame itself was visible beneath the body. Two parallel longitudinal rails made from channel section steel. These were connected by perpendicular crossmembers, creating a ladder structure. Bellini examined the frame construction. The channel steel was simple rolled stock, inexpensive and universally available. The design was inefficient from pure weight optimization perspective. Engineers could design lighter frames using advanced techniques, but the American design prioritized manufacturing simplicity over weight savings. Any factory with basic metalworking equipment could produce these frames. No specialized knowledge required beyond fundamental welding skills. A shop that built agricultural equipment could manufacture Jeep frames with minimal retooling. That was strategic genius. Production could be distributed across hundreds of facilities. If one factory was damaged, others could compensate. He examined the suspension system. Leaf springs front and rear, 19th century technology. Italian engineers had moved to independent suspension with coil springs. Leaf springs were crude, harsh, obsolete, yet the Americans had deliberately chosen them. Bellini considered why. Leaf springs were simple to manufacture. Flat steel bars, heat-treated, stacked together. They combined spring function with structural load-bearing. They could be repaired in field conditions with basic metalworking skills. If a spring broke, an improvised replacement could be fashioned from any piece of spring steel. Coil springs required specialized manufacturing equipment. They couldn't be easily repaired. If one broke, replacement was the only option. The Americans had chosen reliability over refinement, chosen repairability over performance. He crawled underneath the vehicle. Everything was exposed, no protective panels, nothing hidden. The exhaust pipe ran along the frame's right side. The fuel tank was mounted behind the driver's seat, clearly visible. The transfer case, connecting front and rear axles, could be accessed from above. This was revolutionary. Italian vehicles buried components inside complex housings. Access required disassembly, removal of covers and shields. A simple task like checking differential oil might require 30 minutes of preliminary work. The Jeep eliminated that. Every major component could be reached without removing anything else. Bellini opened the hood. The engine sat in the bay, compact and simple. 4 cylinders in line. Overhead valves actuated by push rods, side-mounted carburetor, belt-driven fan, oil filter, cartridge on the left, distributor at the front, everything visible, everything accessible. He had expected complexity. American industrial capacity suggested advanced engineering. Instead, he found primitive simplicity executed with precision. There was nothing innovative about this engine. It used technologies from the 1920s. Inline 4-cylinder, overhead valves, side carburetor, conventional distributor, ancient, basic, crude. But it worked. The engine displaced 54.9 cubic inches, approximately 2.2 litres. Maximum output 134 horsepower at 4,000 revolutions per minute. These were modest numbers. His Fiat engine produced 85 horsepower from 4.5 litres, nearly twice the volume. But the Jeep's engine weighed 63 pounds according to technical documentation. The Fiat's engine weighed 1,190 pounds, nearly 1,200 pounds of cast iron and aluminum. Bellini calculated power-to-weight ratios. The Jeep's engine produced 2.1 horsepower per pound of engine weight. The Fiat produced 0.07 horsepower per pound. The Americans achieved 30 times better power to weight. 30 times. That was a completely different philosophy. By choosing a small, lightweight engine, the Americans had created a vehicle that could achieve strategic mobility the Italians couldn't match. Less weight meant better fuel economy. Less weight meant reduced strain on all components. Less weight meant the vehicle could operate on lighter bridges, narrower roads, softer terrain. And paradoxically, the smaller engine was more reliable than the larger Italian engine. He called Romano over. "Lieutenant, Record measurements as I work. We'll document everything systematically. For the next 6 hours, Bellini examined the engine in place. The engine block was cast iron, one-piece construction, simple sand casting, surface rough but functional. The cylinder head was also cast iron, mounted with 10 bolts of identical size. Bellini measured them, 9/16 inch diameter, standard thread, every bolt the same. He compared this to the Fiat engine. Its aluminum head required 14 bolts of 3 different sizes, tightened in a specific sequence. The Jeep's head could be installed by anyone who could turn a wrench. The crankshaft ran on 3 main bearings, adequate but not excessive. Italian engines typically used 5 or more for smoothness. The Americans had determined that 3 was sufficient. Fewer bearings meant simpler design, easier manufacturing, reduced cost. The connecting rods were forged steel, simple I-beam cross-section. They were overbuilt for the power output, incorporating significant safety margins. By making components stronger than necessary, the Americans ensured they could survive abuse. Italian components were engineered precisely to calculated loads. They were efficient, optimized, refined. They were also fragile. The Americans had deliberately accepted weight penalties to gain reliability margins. The carburetor was a single-barrel downdraft design, the simplest possible. 1 main jet, 1 idle jet, basic float mechanism. Adjustment required only a screwdriver. The ignition used a conventional distributor with mechanical points and condenser, 1920s technology. The spark plugs were standard 14mm thread used in countless civilian vehicles worldwide. Bellini removed the valve cover. 4 bolts. Underneath, the valves, push rods, and rocker arms were visible. He measured valve clearances. They were generous, approximately 15 thousandths of an inch. Italian engines used 5 to 8 thousandths. The Americans had allowed looser tolerances. This meant valves could wear significantly before adjustment became necessary. The cooling system used a pressurized radiator and belt-driven water pump. The radiator core was copper and brass, expensive but easily repaired. Any metalworker could solder a damaged core. The Americans had chosen repairability over weight savings. The fan was fixed to the water pump shaft, no complex viscous clutch. When the engine ran, the fan ran. Inefficient because the fan consumed power even when cooling wasn't needed, but foolproof because there was nothing to fail. The fuel system was simple. Steel tubing with compression fittings. Mechanical fuel pump driven by the camshaft. No electrical components. The air cleaner was an oil bath type, particularly effective in dusty conditions. Incoming air passed through oil that trapped particles. Maintenance required only draining dirty oil and refilling. Italian vehicles used paper filter elements that clogged in hours and required replacement. The oil bath design couldn't clog. It continued functioning even when saturated with dust. By evening, Bellini sat surrounded by notes. Romano brought coffee. "Captain, what are you thinking?" Bellini was quiet. "I'm thinking the Americans have designed an engine that refuses to die. An engine that survives mistakes, abuse, neglect." Romano looked skeptical. "But our Fiat engines produce more power, run more smoothly, consume less fuel per horsepower. By every engineering metric, they're superior." "Yes," Bellini agreed. "Our engines are better in every measurable technical parameter. Except one." "Which one?" "They keep running." If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The next morning, Bellini began full disassembly. The valve cover came off with 4 bolts. The cylinder head required 10 bolts, all the same size. The head lifted free, revealing simple combustion chambers. He examined the pistons. Cast aluminum, basic design. The rings were conventional, nothing sophisticated, but adequate. The complete disassembly took 2 days. When finished, every component was laid out on tables, organized by system. Bellini counted parts systematically. The entire engine consisted of approximately 320 individual parts. His Fiat 634 engine contained over 600 parts. The Americans had eliminated half the complexity while maintaining functionality. This was the key insight. Every part the Americans removed was one less component to manufacture, inspect, assemble, and maintain. One less potential failure point. He examined manufacturing techniques. The engine block had sand casting marks, rough surfaces. The Americans hadn't wasted time finishing surfaces that didn't affect function. The crankshaft was forged, then only bearing surfaces were machined precisely. The rest remained rough. The connecting rods were forged identically, completely interchangeable. Any rod fitted any piston on any journal. This simplified assembly enormously. Italian rods often required selection and matching. The Americans had chosen ratios favoring torque over speed. Maximum velocity was, perhaps 100 kilometers per hour, but low-range gearing could pull the vehicle through terrain that would stop conventional trucks. By the third day, he had documented everything. The Jeep lay in pieces. Romano had filled 4 notebooks. Bellini wrote his preliminary report. The numbers told a story. The Jeep's engine weighed 63 pounds and produced 134 horsepower. Power-to-weight ratio exceptional. But more important was what Bellini called the simplicity ratio. He calculated it by counting unique part designs, specialized tooling requirements, and precision machining operations. The Jeep scored remarkably low. An American factory could produce these vehicles with minimal specialized equipment. Training requirements were low. Quality control was simplified by generous tolerances. He compared this to Italian vehicles. The Fiat required specialized tooling throughout. Skilled assembly was mandatory. Manufacturing time per vehicle was approximately 200 hours. Intelligence reports suggested Americans were building Jeeps in under 20 hours. 1/10 the labor investment. The mathematics became clear. For the same industrial investment, America could produce 10 vehicles for every 1 Italian vehicle. Those 10 vehicles would be collectively more capable, because reliability multiplied effectiveness. Bellini wrote in his report, "The American philosophy represents industrial warfare in its purest form. They have eliminated engineering elegance in favor of mass-producible adequacy. This is not weakness. It is fundamental strategic advantage that negates our technical sophistication." He continued, "Our vehicles are superior in refinement. Theirs are superior in existence. We cannot build enough sophisticated trucks to match their production of simple ones. The outcome is predetermined by industrial capacity, not engineering skill." That evening, a colonel from the Technical Evaluation Office arrived. Colonel Martinelli was place lead 2053, a career logistics officer. He walked through the workshop examining components. "Crude work," he commented, pointing to rough castings. "Cheap materials," he noted. "Primitive design," he concluded. Bellini said nothing. The colonel turned to him. "Your assessment, Captain?" Bellini chose words carefully. "Sir, this vehicle represents a philosophy that negates our advantages. We build trucks requiring skilled operators and experienced mechanics. They build vehicles any soldier can operate and any conscript can repair. We build for quality. They build for quantity. In a long war, quantity defeats quality." The colonel's expression hardened. "You sound defeatist, Captain. That's dangerous." "I sound realistic, sir. These vehicles will flood North Africa. We cannot match their production." The colonel's voice went cold. "Your job is technical evaluation, not strategic assessment. Complete your report on the vehicle's weaknesses." When the colonel left, Romano spoke quietly. "You could be arrested for that." "I know. Was it worth the risk?" Bellini looked at the disassembled Jeep. "Truth is always worth the risk." Over the following week, Bellini conducted operational testing. He reassembled the Jeep, a process taking 12 hours. He tested it across varied terrain, desert sand, rocky hills, dry riverbeds. The Jeep performed consistently. High ground clearance prevented bottoming out. Four-wheel drive provided traction in loose sand. He measured fuel consumption, 7.5 kilometers per litre under combat conditions. Not impressive, but adequate. The 15-gallon tank provided range of approximately 450 kilometers. He tested maintenance procedures. Oil change took 10 minutes. Spark plug replacement, 8 minutes. Air filter service, 5 minutes. An American motor pool could service 10 vehicles in the time Italian mechanics serviced one. But the most important test came unexpectedly. During a night exercise, the Jeep's engine overheated catastrophically. Water pump failure. The engine seized completely from thermal expansion. Bellini expected total destruction. He waited for the engine to cool, then added water from his canteen. He attempted restart, expecting nothing. The starter cranked, the engine caught, rough at first, knocking badly. Then it smoothed out. He disassembled the engine immediately. The aluminum pistons had expanded in the cast-iron cylinders during overheating, seizing solid. But when cooled, aluminum contracted faster than iron. The pistons loosened. When he restarted with fresh coolant, residual oil was enough to free them completely. The Americans' material choices had accidentally created a survivable failure mode. Italian engines used aluminum for both blocks and pistons. When they overheated, everything expanded uniformly. Once seized, they stayed seized. The crude American design survived conditions that permanently destroyed Italian sophistication. By mid-December, Bellini completed his evaluation. The final report ran to 87 pages with detailed drawings, performance data, and manufacturing analysis. His conclusions were unmistakable. The American light utility vehicle represents a strategic threat more significant than any specific weapon system. Its simplicity enables mass production Italy cannot match. Its reliability enables sustained operations impossible with Italian vehicles. For equivalent industrial investment, America produces 10 vehicles to our one. Their 10 vehicles operate at 90% availability, while our one operates at 50%. The effective ratio is 18-1 in America's favor. No tactical skill can overcome 18-1 logistics superiority. He submitted the report, knowing it would be suppressed. 2 days later, Bellini received new orders. Transfer to a maintenance battalion in Tunisia. Frontline duty. Effective immediately. The transfer was obviously punitive. Romano brought the orders. They're burying your report. I know. What will you do? Bellini looked at the Jeep one final time. I'll do my duty. I'll maintain our trucks as long as possible. Bellini was silent. Then we'll have lost, just as the mathematics predict. January 1943. Tunisia. Bellini arrived at the maintenance depot outside Tunis. Dozens of Italian trucks sat immobilized, awaiting parts that would never arrive. Of 260 trucks assigned, only 73 were operational. Average time to repair a Fiat with blown head gasket was 18 days, assuming parts arrived. Average operational life before next major failure was 300 kilometers. Trucks broke faster than they could be fixed. Bellini established brutal triage. Vehicles with minor problems received immediate attention. Vehicles requiring major work were cannibalized. Vehicles beyond repair were stripped completely. His mechanics, mostly conscripts with minimal training, struggled with complex repairs. The Fiat trucks punished mistakes mercilessly. Meanwhile, intelligence reports described endless American convoys. Jeeps, Dodge trucks, GMC, 2.5 tons. February brought crisis. Rommel launched his counter-offensive at Kasserine Pass. Italian and German units advanced, then stalled when supplies failed to reach forward positions. Bellini's depot received desperate requests. He had 23 operational vehicles. Requests required over 100. Even those trucks broke down en route. One fuel truck lost its entire load when an untrained conscript over-revved the engine, destroying it. 5,000 litres of precious fuel sat unreachable. Bellini led a recovery team. They found the truck strafed by Allied aircraft. The fuel had drained into sand. Total loss. On the return journey, Bellini's vehicle broke down. Fuel pump failure. They were stranded when a British patrol appeared. A jeep stopped 50 meters away. 3 soldiers dismounted. The British sergeant approached. "Broke down, did you?" Bellini nodded. The sergeant smiled. "Happens to the best. Well, not to this." He patted the jeep's hood. "This bloody thing never stops." While waiting for prisoner collection, Bellini studied the vehicle. It was worn, paint faded, canvas shredded, but the engine idled smoothly. "How long have you had this vehicle?" Bellini asked in careful English. The sergeant glanced at him. "Since Tobruk. 11 months. Any major repairs?" "Changed the oil when we remember. Patched the radiator twice. That's about it." 11 months of desert warfare. Minimal maintenance. Still operational. Bellini's vehicles lasted weeks before breaking catastrophically. Back at the depot, operational trucks dropped to 41 by March, then 27 by April. Bellini spent 18-hour days performing repairs. Romano worried. "Captain, you need rest." "Rest when the trucks are fixed." "They'll never all be fixed." Bellini paused. "Yes, I know, that." By May, the Tunisian campaign was collapsing. Bellini received orders to destroy all vehicles. It took 3 days to destroy what had taken months to build. May 9, 1943. Axis forces surrendered. Over 250,000 soldiers became prisoners. Bellini was loaded onto trucks for transport to prison camps. The trucks were American GMCs. Bellini studied the vehicle even as a prisoner. They drove for 6 hours. The truck never faltered. In the prison camp, Bellini discussed the campaign's failure with other engineers. Most blamed tactics, leadership, numbers. Few acknowledged industrial reality. One evening, he spoke with a German engineer. The man was bitter. "We built the best tanks in the world. But did you build enough of them?" Bellini asked quietly. The German fell silent. Finally, he muttered, "Never enough." "That," Bellini said, "is the entire lesson." Months passed. Italy surrendered in September. Bellini spent captivity teaching mechanics to other prisoners. He taught American methodology without calling it that. Simplicity first, reliability over refinement, function over form. A British intelligence officer interviewed him. Major Harrison had obtained Bellini's original report. "Captain, this is remarkable work. Your analysis is more accurate than most of our own engineers' understanding." Bellini shrugged. "I documented what I observed." "You understood the strategic implications. After the war, Italy will need engineers who understand modern industrial methods." After Harrison left, Bellini thought about reconstruction. The war had destroyed much, but revealed truths. Italy had believed sophistication would prove decisive. Instead, sophistication had proven fatal. Complexity had collapsed. Perfection had been defeated by adequacy. America had won by asking better questions. How to build vehicles anyone could maintain. How to design systems that forgave mistakes. How to create processes that could scale, indefinitely. Bellini pulled out his notebook. He began recording principles for post-war reconstruction. Design for maintenance, not just performance. Build for users, not engineers. Simplify until further simplification reduces function. Standardize everything possible. Accept adequate solutions over perfect ones. These were American principles, but they were also universal truths about industrial design. He wrote one final note. The Americans won because their machines were built for soldiers, not for engineers. In the next war, if there is one, every nation must remember this. May 1945. The war was over. Bellini returned to Italy to find his country devastated, but rebuilding. He found work in Milan, repairing engines for Allied vehicles left behind. Among them were hundreds of jeeps. The same machine that had carried soldiers through war now carried farmers, doctors, builders. Bellini's hands remembered every bolt. He could remove the transmission in minutes, fix the clutch with scrap metal, tune the carburetor by sound. Each repair was a strange confession. When asked by an American officer to train Italian mechanics, he agreed. "Teach them simplicity," the officer said. Bellini smiled. "I can do that." By the early 1950s, Italy's new automotive industry took shape under a different philosophy. Gone were the over-designed war machines. In their place came small, reliable cars. Volkswagen, Opel, Mercedes, all rediscovered building for the many, not the few. Bellini visited the Volkswagen plant once. He touched one of the hoods and thought, "This is what we should have done from the beginning." In 1949, Time magazine called the Jeep the greatest instrument of democracy ever built. Bellini clipped the article and kept it. He grew old quietly. Every few years, he'd see a Jeep pass by, and he'd smile. The sound of that engine always brought him back to the Benghazi basement when his world was collapsing. In 1973, he spoke at a technical university in Munich. Students had found references to his anonymous report. One young man asked, "If you could summarize the difference between their engineering and ours, what would you say?" Bellini thought for a long moment. "We built machines that demanded respect. They built machines that earned trust. Respect ends with fear. Trust endures." The auditorium fell silent. He died in 1981 at 72, leaving no patents, no medals, no headlines, just notebooks filled with numbers and sentences that read more like philosophy than engineering. His tools were donated to a trade school. On the wall above his workbench, his apprentices hung one of his sayings. "The measure of a machine is not how perfectly it is built, but how many lives it improves." Today, the Jeep still drives on. It has outlived the factories that mocked it and the empire that tried to dissect it. Somewhere in its steel frame, the ghost of an engineer's epiphany remains. Marco Bellini was never called a hero. His victory was not in battle, but in understanding. In a war that worshipped perfection, he found peace in imperfection. The 63-pound engine had taught him that engineering excellence is measured not by sophistication, but by suitability to purpose. That crude designs perfectly suited to their purpose represent true engineering. That sophistication poorly suited to reality is mere vanity. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.